to the next lecture on the network theory, that is two-port network. Two-port network is supposed to be a very important module in the network theory or network analysis. Most of the students will opt for this module. So, this module consists of, you can see that the contents that I am going to do in this module is introduction of the two-port network and impedance parameters, conditions for reciprocity and symmetricity, and examples, few examples on the evaluation of the impedance parameter. So, the learning objectives in this two-port networks, the first lecture on this is describing the students will be able to describe the two-port networks and able to represent a two-port network, identify the independent sources and dependent sources of the two-port network, and define the parameters. It can be impedance parameter or admittance parameter and so on. So, those parameters will be defined in this lecture. What is a two-port network? So, before starting with the two-port network, let me tell you about what is a port is all about. A port consists of a pair of terminals at which the electrical signals may be entering to the terminal, or it can exit or leave the from the terminal in a network, and that terminals, a pair of terminal is called as a port. Okay, so far you have studied about one terminal network, okay, and one terminal network is called as a one port network. Okay, but in this lecture we are dealing with the two port network. So, it is a two terminal network. So, that two terminals, why we call that as a two terminal, we will see in the next slide. So, two terminal network and its behavior, okay, so that we are going to explain, I am going to explain in this lecture. Okay. So, for this two port network we may apply input signal at one of the port, and you can obtain an output signal from the other port. Okay. The parameters of this two port network, okay, it is completely described by its behavior in the terms of the voltage and the current at each port. Okay, and they are very common in the electronic systems such as communication system, transmission systems and the distribution system. Okay. So, in order to describe the behavior of the two port network, we have totally 6 parameters. So, out of this, very important parameters are impedance parameter, admittance parameter, hybrid parameter and transmission parameter. So, this is the representation of the two port network, where you can see a linear network we have considered. So, the linear network we have a one pair of terminals, and this is called as a one port network. Okay. So, again, so here you can see that two terminals are attached to this network, and these two terminals can be considered as input terminals or input port. Okay, input port, I can write it as input port. Similarly, I can also write a network consists of another pair of terminal. Let us consider this also as a linear network. Okay, even this is also having a voltage and the voltage and the current source here. So, sorry, current flowing through this terminal, and this network is also called as a output network. Okay. So, in one port network, the network will have either the input ports or the output ports, whereas in the two port network you can see the linear network where we have a input port as well as the output port. Okay. And this is considered as input port and this is output port. Okay. So, here we can see there are 4 variables, okay, namely V1 and I1 as well as V2 and I2. So, there are 4 variables here, and it is a two port network. When we have the combinations, okay, permutation and combination, you can have the 6 maximum representations, 6 maximum parameters you can obtain. Okay. So, out of that 6, let me 6 parameters you can obtain. Okay, I will explain what are those parameters. So, before that, let me explain about give an example of the two port network. Okay. So, I have 2 examples of the two port network, namely transistor. transistor is also a two-port network as well as the transformer. Okay, so why transistor is considered as a two-port network? Here you can see you can attach a resistor and you can attach voltage source here. Okay, generator voltage source, and you can get an output V0. So you can here you can see that, let me terminate the emitter to the ground. So you can see that there is a source connected to the transistor as well as you are drawing current or the voltage from the transistor. Here the voltage as an output, V0 as an output, so that means this terminal is a output terminal as well as this terminal is an input terminal. Both input and output terminal exist in this transistor. So this is a good example of the two-port network. Similarly, in the transformer you have a V in input voltage and as well as V out. Okay, it can be a step down or step up transformer. So both it will exist input as well as the output. Okay, so these two are the input terminal. Similarly, these two are the output terminal. So we have input terminal as well as the output terminal in this example. So as I told, we have 4 variables and the 2 ports. So based on this variables and 2 ports, we can have the 6 number of, okay, so 6 number of parameters. So namely Z parameters are the impedance parameters are the open circuit parameters, and Y parameter admittance parameter or short circuit parameter, and we have a hybrid parameter, then we have a ABCD parameter, then inverse ABCD parameter and G parameters. Okay, so for the main parameters that we are going to deal in this lecture are Z parameters, Y parameters, H parameter and ABCD or T parameter. We will take one by one. So let me explain what is Z parameters. So Z parameters are also called as a open circuited parameter. Why we call it as open circuited parameter, we will see. Okay, so these Z parameters, where are the Z parameters are applied? Okay, these Z parameters are applied. Okay, it is very useful in the designing and analysis of the impedance matching networks and as well as the power distribution networks. Okay, and this two-port network, any two-port network, it can be a voltage driven or the current driven. For example, here you consider the two-port network here. Okay, so it is a linear two-port network and the voltage sources are connected to this linear two-port network. This two-port network, it is called as a voltage driven two-port network because it is driven by the voltage sources. Similarly, you can see in the below picture, this two-port network, linear two-port network is driven by the current sources here. So that's why it is called as a current driven two-port network. And the behavior of these two-port networks are expressed in terms of the impedance parameters. So the voltages, let me explain with the voltage network, okay, voltage driven network. So for the voltage driven network, I can write 2 equations. Okay, so V1 equal to Z11 I1 plus Z12 I2. Similarly, V2 equal to Z21 I1 plus Z22 I2. Okay, where Z terms are called as a impedance parameters or simply as Z parameters, and the unit of this impedance parameters are ohms. Okay, the value of these parameters can be evaluated by open circuiting the network. Okay, so for example, so value of the Z11 and Z21 can be obtained by open circuiting the input port as well as open circuiting the output port. By making the I1 equal to 0 or I2 equal to 0, we can obtain the parameters Z11, Z12, Z22 and Z21. So this equation can be expressed in terms of the matrix form. So V1, V2 will be equal to Z11, Z12, Z21, Z22 into I1, I2. Okay, and this Z parameters for the two-port network is 2 cross 2 and this is 2 cross 1 and this also 2 cross 1. Okay. Yeah. Now we will evaluate this equation, okay, by substituting I2 equal to 0. So what we have the equation as, so V1 equal to Z11 I1 plus Z12 I2. Similarly, V2 equal to Z21 I1 Z22 I2. Let me call this as equation number 1 and this as equation number 2. Okay. So now when I substitute I2 equal to 0, what is that means? I am open circuiting the 2-port network. That means we have a 2-port network. Okay. So this is open circuited. We have I1 and V1 I2. Okay. So this the terminal, okay, terminal 2, that is the output port, I am open circuited. So when I do that, so I2 will be equal to 0. Okay. So I2 will be equal to 0. So when I substitute I2 equal to 0 in these two equations, what I will get? So when I substitute I2 equal to 0 in the first equation, this will be equal to 0. The second term in the first equation will become equal to 0. Then the remaining term is V1 equal to Z11 by I1. So from that I have found out what is Z11. Okay. So Z11 equal to V1 by I1 by keeping I2 equal to 0. That means I am open circuiting the second port. Similarly, in the equation number 2, when I substitute I2 equal to 0, so I will get V2 equal to Z21 into I1. Okay. So from that I get Z21 equal to V2 by I1 provided I2 equal to 0. Okay. So similarly, what I will do? So I have open circuited and I have extracted what is the value of Z22 and Z21. Similarly, what I will do? The next step, I will open circuit the input port. Okay. I will open circuit the input port and I will connect the source to the second port, output port. Okay. So what is that means? That means I1 will be equal to 0 now. Again consider the first two equations. So in this we have to consider I1 equal to 0. So when I1 equal to 0, we have Z11 will be, this terms will goes to 0. Okay. What is remaining? That is V1 equal to Z12 I2 and V2 equal to Z22 I2. Okay. So from that first equation, V1 equal to Z12 I2, I have got what is Z12 equal to as Z12 equal to V1 by I2 provided I1 equal to 0. Similarly, Z22 equal to V2 by I2 provided I1 equal to 0. Okay. So we got the expressions for the Z parameters or impedance parameter by considering the ports as a open circuit. That is the reason this Z parameters is also called as a open circuit parameters. Okay. Now this Z11, the parameters Z11 and Z22 are called as a driving point impedances, whereas Z12 and Z21 are called as a transfer impedances. Okay. Z21 is called as a reverse transfer impedance and Z12 are called as a forward transfer impedance. Okay. So the driving point impedance as Z11 or Z22. Okay. So Z11 is called as an input driving point impedance, okay, of the two terminal. So this input driving point impedance, like if it is with like open circuiting the output port open circuiting, we obtain the Z11. Similarly, Z22, the output driving point impedance, it can be obtained by open circuiting the input port. Okay. So how we obtain Z11 and Z22? By open circuiting the other port in the 2-port network. Okay. So we have all the driving points, that is Z11 and Z22, and the transfer impedances as Z12 Z21 and Z22. So only we can observe what is Z11 and Z22 from the terminals, whereas the transfer impedances we can't observe. So that is because it is dependent impedances. That means look at the equivalent circuit of the two port network for the Z parameters. Here you have a voltage source V1, okay, and current flowing through the Z11, okay, that is the impedance, input driving point impedance, and Z12 and I2 as a dependent source here. So Z12 is dependent on the current at the second port. Similarly, Z21 is also depend on the current at the first port, that is I1. Okay, so since because of these two dependent sources, okay, so this Z12 and Z21 are the transfer impedances that we can't actually get it, or we can not see from the ports. Okay, so this is the equivalent circuit of the Z parameters. Okay. So Z parameters obeys the symmetric property and as well as the reciprocity property. So when a network can be called as a symmetric or reciprocal, so let us do the statement, or a two port network, when this will be called as a symmetrical, when any two port network is said to be symmetrical if the ports can be interchanged without port voltages and currents. Okay, so if it is interchanged without the ports voltages and current, then that circuit is called as a, or a network is called as a symmetrical network. Okay, so if the impedance measured at one port, if it is equal to the impedance measured at the other port, okay, with the remaining ports open circuited. In case of Z parameters, when I measure the Z12, okay, so it is open circuited with the port 2. When I measure Z21, so it is open circuited with the port 1. Okay, so if the impedance measured at the one port, if it is equal to the impedance measured at the other port, okay, with remaining other ports as open circuit, then we can match the impedances from the input port and the output port, and we call that as a symmetrical. Okay. So condition for reciprocity, when a network can be said to be reciprocal, when a two port network is said to be reciprocal if the rate of excitation, okay, to the response is invariant to any interchange of the position of the excitation and the response in the network. So what is that means? If the circuit or a network, if it is called as a reciprocal, even if I interchange the excitation, that means the sources, the parameters, okay, Z parameters or H parameters, any other parameters will not change, the value of that will not change. Okay, the two port network is said to be reciprocal if the rate of excitation to the response is invariant to the interchange of the position. Okay, you have to see that interchange of the position of the excitation, okay, and response in the network. Okay, so this type of network we call it as a reciprocal network. So network consisting of resistor, capacitors, inductors are generally reciprocal. Okay, all this networks and these elements in the network, if it is present in the network, we call that network as a reciprocal. So now we have to prove whether the Z parameters are reciprocal and symmetry as well. Okay, in the Z parameters, a network is said to be reciprocal. We know that if the ratio of the response to the excitation remains unchanged, even if with the position of the response as well as the excitation are interchanged. Okay, and if the same parameters, if it is said to be symmetrical, if the two port network, okay, in the two port network, if the input and the output port can be interchanged without altering the port voltages or currents. Okay, so now consider again the equation number 1. Okay, so equation number 1, we have written it as V1 equal to Z11 I1 plus Z12 I2. Okay, so let me rewrite the network here. Okay. So, consider a network, two-port network is connected to a load resistance RL. So, at this point, okay, so at this point you can see the current, okay, so through the RL is IL and it is same as the current flowing through the terminal, this terminal, that is I2. That means IL. So, when I put the KCL at this point, I2 plus IL will be equal to 0. So, let me consider this node as A. So, at node A, okay. So, at this point, so the current going out of the node, I consider this a positive, I2 plus IL, okay, which is equal to 0 by applying the KCL at node A, okay. So, from this we can see that I2 or IL will be equal to minus I2. IL will be equal to minus I2, okay. So, I can consider IL as a minus I2 or I2 as a minus IL, both are same, or I2 as minus IL, okay. So, this IL, since it is same as the I2, I can consider this I2 will have same value as that of the IL will have the same value as that of the I2. I can consider that this is also an I2 but in the reverse direction. So, I denoted it as a I2 prime, okay. So, this you have to remember. So, we have considered the two-port network and we have connected a load, okay. The current flowing through the load is a I2 dash, okay, I2 prime minus I2 dash, that refers to the direction of the flow of current with respect to the I2, okay. Again, so considering again the first equation, okay, voltage equation V1 equal to Z11 I1 minus I2 dash into Z12, okay. So, this V1 we considered as a source. Here you can see this network shown here. So, this V1 is considered as a source voltage, okay. So, again I2 will be considered as a minus I2 dash, okay. So, we know the reason, just now I have told, we know the reason why I2 is considered as a minus I2 dash, okay. So, now like by making V equal to 0, okay, by making V equal to 0, that means by short circuiting the first port, okay. So, we consider the equation as V equal to 0, that is Vs equal to 0, that is port 1 is short circuited. Then we rewrite the equation as 0 equal to Z11 I1 minus Z12 I2 dash, okay. From that we get what is the I1 expression. So, what is I1 expression? I1 equal to Z22 by Z21 into I2 dash, okay. So, now substitute this I1 once again into the V1 equation. So, V1, that is nothing but the Vs. So, V1 equal to Vs, which is equal to Z11 into I1. So, I1 is nothing but now Z22, Z21 I2 dash minus Z21 I2 dash, okay. By simplifying we will get I2 dash. From this we get I2 dash as Z21 by Z11 Z22 minus Z12 Z21 into Vs, okay. So, for the reciprocity, I1 dash must be equal to I2 dash, okay. So, now we have found what is I2 dash. Now, next we will find what is I1 dash, okay. So, in order to find the I1 dash, again we have to short circuit the V2, that is the port 2, okay. So, we will short circuit the port 2, okay, and we will evaluate what is I1 dash. So, again we know what is I2 dash as, okay. So, I2 dash is nothing but I2 is nothing but Z11 by Z12 into I1 dash. So, substituting in the considering V2 as a like V2 as Vs, considering the second equation in the voltage equations of Z parameter, second equation where V2, the second port voltage, is nothing but the Vs source voltage, which is equal to minus Z12 into I1 dash plus Z11 by Z12 into Z22 into Z22 into I1 dash. Okay. So, this will be again summarized as I1 dash equal to Z12 divided by Z11 Z22 minus Z12 and Z21 into Vs. So, now you compare this equation I2 dash and as well as I1 dash. So, only the numerators, okay, in I2 dash and I1 dash are equal to Z1, Z12 and Z21 respectively. So, this, if this should be equal for the reciprocity, that means even the Z12 should be equal to Z21. Okay, if the network, if it is reciprocal, so what is that means? That network should have the parameters, that is Z12 equal to Z22. That means I2 dash, in that point the I2 dash will be equal to I1 dash. Okay. So, this shows that the even we interchange the responses and the excitations. Okay. So, we will get the same current and the Z21 will be equal to Z21, sorry, Z12. Okay. So, we have proved that Z12 will be equal to Z21. Okay. So, what is the condition for the reciprocity? The condition for reciprocity is Z12 will be equal to Z21. This is the condition for the reciprocity. Okay. So, now we will move on to the condition for the symmetric. Okay. So, before that let me evaluate one circuit for the Z parameters. So, here find the Z parameters of the two port network. Okay. So, here you have a two port network. Okay. This is V1, V2 and the resistance 10 ohms, 20 ohms and 5 ohms, and this is I1 input current and I2 output current. Okay. So, in order to find the parameters, first finding the Z parameters. Okay. So, let me open circuit the port 2. Okay. When port 2 is open circuited, then I2 will be equal to 0. Okay. So, when I2 becomes 0, then 20 ohms will be will not be there in the network. Then find what is the I. Okay. By applying KVL, to the resultant network, we have I1 will be equal to 10 into let me write. Okay. So, V1 will be equal to 10 into I1 plus 5 into I1, which is equal to 15 I1. That means V1 will be equal to 15 I1. Okay. So, from this again in the second loop V2 will be equal to 5 I1. So, why? Because whatever the voltage across this will be equal to the voltage across this terminal. Okay. So, V2 will be equal to the voltage across the 5 ohms resistor. So, the V2 will be equal to 5 into I1. So, voltage across the 5 ohms resistor is nothing but V2, which is equal to 5 into I1, because I1 is the current flowing through the 5 ohms resistor. Okay. So, from this we know the expression for the Z11. Z11 is nothing but V1 by I1 provided I2 equal to 0. So, we have already open circuited the second port. So, Z parameter, that is first parameter Z11 will be equal to V1 by I1. Okay. So, V1, we know what is V1, 15 into I1, and what is we will substitute in this, we will get 15 into I1. Let me substitute V1 as 15 into I1, and at the denominator we have a I1. So, I1 get cancels, we have 15 ohms as a Z11. Okay. Similarly, Z21 expression is Z21 equal to V2 by I1, okay, with the I2 equal to 0. Okay. So, Z21 equal to V2 by I1, okay. So, which is equal to, what is V2 now? It is 5 I1 divided by I1, okay. So, it is I1 get cancels, this will be 5 ohms. So, we have got 2 parameters out of 4 parameters, that is Z11 and Z21 by keeping the output port open circuit. Okay. Similarly, in order to evaluate the other 2 parameters, that is Z22 and Z12, so we will open circuit the input port. Okay. So, by open circuiting the input port, so V1 I1 will be equal to 0. So, we have V1 as the input voltage. Again the 10 ohms resistance will be redundant, then the current flowing through this we will take and we will apply the KVL. And also, what is V1? V1 is nothing but the voltage across this resistor. So, that will be equal to V1. Okay. So, voltage across the resistor 5 ohms, which is equal to I2 into 5. Okay. So, we will write what is the equation KVL. After applying the KVL equation to the output port, we have V2 equal to 20 I2 plus 5 I2, which is equal to 25 I2. Okay. So, Z22, in order to evaluate the Z22, we have Z22 equal to V2 by I2, which is provided the I1 will be equal to 0. So, by substituting what is V2, that is 25 I2, and in the denominator also we have a 20 I2. So, I2 will get cancelled, remaining is the 25 ohms. Okay. Z22, okay, output impedance as Z22 equal to 25 ohms. Okay. So, as I told, the voltage across the 5 ohms resistors is nothing but the V1. So, V1 will be equal to 5 into I2. Okay. So, we know the expression for the Z12 as V1 by I2 when I1 equal to 0. So, this will reduce to 5 ohms now. So, again, so we can write what are the parameters. We have Z11 equal to, yes, Z11 equal to 15 and Z21 is as 5, yes, Z11 as 15 and Z21 as 5 ohms. Okay, we have got the values Z11 and Z22 for this circuit. Okay, so and even the Z12 and Z21. Okay, all the 4 parameters of the impedance are open circuit parameters we have evaluated for this network. We will move on to the next example. Okay, this is an example of the dependent source. Okay, where the dependent source value is 3 by 2 V2. Okay, so this current source, dependent current source, it is depend on the voltage V2. Okay, in such kind of network, how to evaluate the Z parameters. Okay, again we will apply the same method, open circuit one of the port and evaluate the parameters. Okay, and again open circuit the other port and evaluate the parameters. So, let us consider the open circuit the second port. Okay, port 2 is open circuited. Okay, so from the port 2, if it is open circuited, then I2 will be equal to 0. Okay, so we will apply the KVL for this. We will obtain what is the equation for the V1. Okay, after applying the KVL equation for the second port open circuited, we have V1 equal to 6 into I1 plus 2 I3 plus 4 I3 equal to V1. Similarly, the voltage across the 4 ohms is nothing but the V2, which is equal to 4 into I3. Why I3? Because I3 is the current flowing through the 4 ohms. So, voltage across the open circuit voltage will be equal to the voltage across the 4 ohms, which is nothing but a 4 into I3. Okay. So, now applying the KCL at node B, we have I1. Okay, that is the input to the node. Okay, I1 minus 3 by 2 V2 minus I3, okay, equal to 0. Okay. So, from this we will evaluate what is I1. I1 will be equal to 3 by 2 plus 1 by 4 into V2, which is equal to 7 by 4 into V2. So, from this again we can see that we can substitute what is the I3. Okay. So, from this equation, we have what is I3. Okay, so I3 will be equal to V2 by 4. So that is substituted in this equation. Again it will be simplified as this. Now we have V2 equal to 4 by 7 I1. Similarly, so from this we know what is V2, okay, and we know what is V1. Okay, so from this we will evaluate what is Z11 and Z22. Okay, so but we want what is Z22 first. So for that Z21, for that we have Z21 equal to V2 by I1 when I2 equal to 0. So by substituting the values we have 4 by 7 ohms, where V2 we know what is V2 as it is 4 into I3 and I1 as 7 by 4 V2. So after substituting this we have the Z21 equal to V1 by I1, which is equal to 4 by 7 ohms. Okay. So from this again we can find out what is the I3. So I3 will be again V2 by 4, we will consider that. Again V2 also we know from the previous, we have evaluated what is the V1 here, okay, and by substituting, so we will obtain what is Z11 as V1 by I1 with I2 equal to 0, which is equal to now 48 by 7 ohms. Okay. Now it is time to find out the other two parameters Z22 and Z12. Okay. So by open circuiting the first port, that is port 1 dash, we have the other, we can evaluate the other parameters for this network. Okay. So by open circuiting we can apply the KVL to that network. So 4 into I4 minus I2. Okay. So see here, by applying the KVL through the 4 ohm. So 4 into I4 minus I2 plus I2 into I4 again plus V1. Okay. So by doing this we obtain what is the equation for the I4, that is I4 equal to 3 by 2 V2, okay, and as well as the equation for the Z22, the expression for the Z22, which is equal to V2 by I2. We know what is V2 by I2 as 4 by 7 ohms. So we substituted here and we got the values. Okay. So by filling up all the parameters, Z parameters, after evaluating all the parameters, we obtain Z equal to 48 by 7 and minus 8 by 7, again 4 by 7 and 4 by 7. Okay. So this is your Z parameters for the given example.